Hello GATE aspirants, welcome to GATE Chemical Solution channel. This is 2-mark fluid mechanics question in the year 2021 GATE question paper. Please read the question very carefully and identify what is given and what you have to find out. So if you are well aware of the concept, we can directly go for the problem solution. Now we will see the concept explanation part, then we will go for the problem solution. Okay. What is hydrostatic equilibrium? As per the definition, in a stationary mass of a single static fluid, the pressure is constant in any cross section parallel to the earth's surface but varies from height to height. This is the definition. So let's say this paper is the earth's surface. So this book is at a height some z or whatever it may be. Okay. So if you consider this surface is parallel to the earth's surface, right? Okay, so on this surface, if you consider any direction, yes, this direction, any direction, the pressure is same. In any direction on this surface which is parallel to the earth's surface, the pressure is in all the directions it is the same, only it is varying from height to height. If you go towards the earth's surface, pressure at this point pressure may vary. If you go upward from the earth's surface, pressure again varies. Clear? That is the statement of hydrostatic equilibrium. Okay. So diagrammatically it will be explained by taking a tall column of fluid. The height of the fluid is in the column is ZA. This is the column surface. This is the cross section area of the column, that is S. On this fluid element, three forces are acting. Okay, that is the pressure force, upward pressure force, downward pressure force and gravity force. Okay, so the resultant of all these three forces on a volume element of the fluid of height dz is 0. Clear? So sum of the forces will be 0, right? If there is no any accumulation, any other forces are there, in such case sum of the forces will be 0. So here pressure is defined as force per unit area. Okay, from this pressure force equal to pressure into area. Similarly gravity force mg, right? So based on that, the upward pressure force is P into cross sectional area S minus downward pressure force equal to over a differential element of height dz P plus dP into S. Okay, this is the pressure and this is the area. So this is the pressure force acting in the downward direction and gravity force Ma, right? This is the G, mg, right? This is G, this is the mass density into cross sectional area dz. This is nothing but the volume element, right? So this is the sum of the forces equal to 0. So PS will get cancelled. Okay, so minus will come, it go that side. This is the expression. From this dP equal to minus G rho dz. Okay, so by integrating this one, we will get P equal to minus rho GH. Why we will get the minus sign here? Here the minus sign indicates if you go from in the earth atmosphere, if you go from the higher altitudes, the pressure is decreasing. Why? Because atmospheric pressure is nothing but the pressure force of the air, right? Okay, so if you go higher altitudes, what happens? The density and amount of the air will be decreasing, right? So in that case the pressure also decreases. That's why the minus sign indicates the if you go higher altitudes, the atmospheric pressure will be decreasing. So between two different heights, that is A and B, the pressure difference is given by this expression Pb minus Pa equal to rho g into Za minus Zb. Since minus sign is there, no, that's why Pb minus Pa, Za minus Zb. So that's what pressure only varies with heights, that is P equal to minus rho gh. This minus sign, remember, only in case of atmosphere, while going higher altitudes the atmospheric pressure is decreasing. Clear? So that's what here given. Then now we will go for the problem solution. So in the problem it is given 3 immiscible liquids A, B, C. Specific gravities of liquids are given, that is 1, 2 and 4 respectively for A, B and C. Neglecting the surface tensions, length of the tube L that is wetted by the liquid B. Okay, so this is the liquid A, liquid B, liquid C. Here from this point to this point the distance is 2 centimeters. That's what given in the problem, and they have asked us to calculate what is the length of the tube that is wetted by the liquid B. Clear? And both tank tubes are operated at atmosphere. This is also exposed to atmosphere and this is also exposed to atmosphere. Okay, clear? So let's say this is also exposed to atmosphere from the question, and this is also exposed to atmosphere. This is liquid A, liquid B and liquid C. Height of liquid A is 4 centimeters. Complete height of liquid B also 4 centimeters, but at the center of liquid B, that is 2 centimeters below the liquid a tube is present. So this tube is wetted by the liquid B, right? And the third liquid is C liquid. The height of the third liquid is 2 centimeters. So I have indicated, given some certain notations for this each fluid heights, HA, HB1, HB2 and HC. Okay, so let's say this is the point 1 or location 1 and this is location 2. Okay, this is one more location. So as per the hydrostatic equilibrium, what we know that the pressure parallel to the earth's surface is same, right? So here the pressure, whatever may be the pressure at this position is same as at this position. So the pressure at this position is atmospheric pressure plus, so sum of the all pressures are acting downwards, acting in this direction, right? So atmospheric pressure plus, due to hydrostatic equilibrium, height of this fluid is rho GH. Okay, rho GH formula. From this pressure applied by this fluid equal to rho A GHA plus, and at this part, so pressure applied by this much portion of the liquid B is rho B GHB1. Clear? So the total pressure at the point 1 equal to this one, and the same pressure is acting here also. So I can equate this pressure at point 2, and by calculating the same pressure is equal to pressure acting in this direction, right? Okay. So if you consider from this direction, this pressure should be equal to this pressure also. So PA plus rho A GHA plus rho B GHB1 equal to atmospheric pressure from this direction plus rho B G RM, this height of this fluid, the inclined tube fluid height, rho B G RM. Since it is inclined, so we can resolve these components, that is r sin theta, r cos theta, like that we have to resolve, no? So by resolving that, the problem they have given the angle, this angle they have given, that is 60 degrees. So this is 90, if you resolve it 90 degrees, it is 30 degrees, right? So I have taken as this angle. So from this, sin theta equal to sin 30 equal to what? Opposite by hypotenuse, right? So Rm divided by L. Sin theta is 30 equal to Rm divided by L. By substituting Rm in place of Rm, sin theta, sin 30 degrees into L, we will get atmosphere will get cancelled. Rho A, G will be common all the terms, so G will be get cancelled. So by substituting the corresponding values, okay, by substituting the corresponding values, they have given the specific gravities, right? So by conversion from the specific gravity, how can you calculate the densities? Specific gravity into density of the standard fluid, that is water, since all are liquids, right? So water is the standard fluid. So specific gravity into density of water in gram per cc is 1. So by multiplying with all this one, we will get 2 gram per cc, 4 gram per cc for C liquid, B liquid and B liquid and A liquid, right? So by substituting the rho A, HA rho b HB1 equal to rho b L sin 30 degrees, right? So by substituting corresponding values, so by calculating here we will get L equal to 8 centimeters. Clear? I hope all of you understand this problem. So if you have any doubts regarding this one, please comment in the comment section. If you like the video, share it and subscribe the channel. Thank you.